Hi, Assalamualaikum. May peace be upon you all. Okay, so I hope this is the last video lectures of probabilities, and I hope you have understood what I have explained before. Okay, so I'm going to continue with Bayes' theorem. Okay, so just a recall, Bayes' theorem, basically it is a conditional probability. It's using multiplication rule 2 for dependent event. Okay, so in this case, okay, we have calculated before, okay, to find probability of A after event B or after event C. So how do we calculate the inverse, that is probability of event C after event A? So in order to do that, we can use Bayes' theorem. So Bayes' theorem is used, okay, when the inverse probability is known. So this is the formula of Bayes' theorem. Probability of A after event B is equal to probability of B after event A multiplied with probability of A. Remember, look at the location here, the ones at the back. Okay, you multiply with the ones at the back and divided with the probability of B, the one at the front. Okay, why do I say this is actually a rule multiplication 2? Okay, so we know that rule multiplication 2 is probability of B after event A times probability of event A equals to probability of event A and B. Okay, so with the reasoning of intersection of A and B is equal to intersection of B and A. So this is the same. So by using basic mathematics, okay, you just change the location of the formula. Okay, you can see that this is probability B. Okay, probability of A and B is equal to probability of B times probability of A given after probability of B. Event B is equal to probability of B after event A times with the probability of event A. Okay, so to get a probability of A after B, okay, you just bring down this. Okay, change it to the left hand side, so you have to divide with probability of A. Okay, so same with this. So this is probability of A. Probability of A occur after event B happens. Okay, so you bring down the probability of B to the right hand side. So we have probability of B after event A times with probability of A divided by probability of B. Alright, so let's calculate that. Can you use the formula here to calculate the probability of C after event A happen? We know that probability of AC is 0.8. So probability of CA is equal to probability of A after C, that is 0.8, times probability of C, that is 5 over 10, divided by probability of A, that is 6 over 10. Okay, so give me the answer for that. Okay, and we'll look at the second example here. Okay, this is another type. This is also a contingency table. Okay, but in this time, we don't have a total. Instead, we have this probability of event A after event B and probability of event not A after B. Right. Now, so if given to us, okay, is probability of B 0.65, okay, and probability for A with B happening is 75. So you can replace this. Okay, probability of B with 0.65. Okay, and probability of A happens after B is 75%, so 0.75. So can you calculate the intersection of probability of the intersection of A and B? Okay, so as I show here, okay, probability of A and B divide by 0.65, and you will have A and B. So this is rule multiplication number 2. Okay, the answer will be 0.4875. Now, can you find this? Probability of not A and B. Okay, then this is also rule multiplication number 2. Okay, or if it's not given, okay, you can calculate A and not B. Right, now we want to find what is the probability of not A after not B here. Okay, it's given to us probability of A and not B is 0.4. Okay, so after that, okay, use a complementary rule as well, okay, to calculate Y. Okay, so summation of this should get 1. Okay, so please tell me what is the answer for Y. Okay, now as a conclusion, okay, when we extract knowledge from the experts, okay, we also need to understand what are the uncertainties of the knowledge. Okay, because it's not easy for us to know which is the fact, which is, because it is so used in our daily sentences, uncertainty. So we need to catch this uncertainty, ask the expert if they can give a weightage, percentage of their, or measurement, kind of measurement. Okay, or else we have to do, we have to calculate that ourselves. So there are multiple approaches to handle uncertainty, and probability theory is used to handle situations that involve the uncertainty as well. Okay, so this is the last one video lecture. Please take a picture of the papers of the solution that you have calculated, okay, or you can scan it and upload it in the open learning. I hope you have fun. I hope you have understand all this probability. It's just an easy, simple mathematical formula. Okay, and I'll see you again in next video lecture. Thank you.